Hello everyone. So now we are going to see a program which is used to control the three LED light. So as we know, this is the Raspberry Pi. So here I am connecting a three LED. So the first pin is 5 volt, which is common to every negative end of a three LED. So I connected it a common in a rail of breadboard. And first LED we giving a red LED and green, and next to it is blue. So the pin number of this red LED is 12 GPIO 12, because in Raspberry Pi there is a few pins only support PWM. So one of the pin is 12 and 13 for green and 19 for blue. So the respective pins were connected to the positive end of a LED. So the program is first we setting a normal basic setups of Raspberry Pi, inputting GPIO module, and set mode is equal to GPIO board cam, and the channels are 12, 13 and 19. So after we initializing the setup in GPIO output, so we giving a LED one variable to each LED represent a PWM mode, and with the standard frequency of 120 hertz. Because of 120 hertz, if I give a lower frequency than 60 hertz, then my camera is a 60 hertz camera, so the frequency difference is make leads to flicker in the light in camera that we see in later. So first we initialize starting the all the LED in 0. Once we start, it will automatically pull up. So to handle that pull up, we using this uh, absolute 100, because in LED here the logic is we want to invert. So we inverting the logic. It means if we put 1, the LED will off. If we put 0, the LED will glow. It is a inverse of logic. If high, it's off. If low, it's on. So that's why we using 100. So the absolute function is nothing but returning the positive of a value only. So inside that we creating a while loop to get a user input. So here I have created a menu option, like we can control the LED in both way. Just I run the program. So initially all the LEDs are off. So it's asking for choose the from below options. First one is automatic brightness control and manual brightness adjustment. So it has a two mode which you can just start it. I give one. So you can see the brightness of a three LED simultaneously glowing up. So you can see the starting point of a LED is very low, and it will glow more in time. So let's so it is automatic process of controlling LED. So if you see control plus C, it will execute and ask the again loop. So the logic of this algorithm is I have created a for loop, which is a iteratable DC variable in range of 0 to 100. We know that DC I mean duty cycle is range to 0 to 100, so we setting a range of 0 to 100 and increase in 1. First LED we simultaneously increasing the LED DC minus 100. So as I said that we want to invert the logic, so we want to minus from 100, it will give a negative value. So to change the negative value, you using absolute function to convert the negative value, and same as the to decrease the brightness from high to low, we using 100 starting value 100, and in step value is minus 1, and from the end value is minus 1. So we putting this for two for loop under a while loop. So to execute in uh, infinity time, whenever a keyboard interrupt is occurred, print exited and change the values of duty cycle of 3 LED to pull down the zero light. See, if I stopped that program, the all the LED were off. So for this purpose, we using this duty cycle of 100 to pull down the value of LEDs. So next, we will give a option of 2 manual control brightness. So if I it's asking for me to enter the brightness for LED 1, so it's not clear in the video. So we enter LED 1, which is red light, we entered 0, and it asking for LED 2, we enter 10 percentage of glowness, and it asking for LED 3. So I give 100 percentage brightness for blue LED. So the first LED is red, second LED is green, and LED 3 is blue. So respectively, if I press enter, you can see the first LED red is 0, and the green LED is 10 percentage brightness, and third LED is 100 percentage brightness. So since we know the duty cycle is directly proportional to the brightness of a LED, so the high brightness of a LED which leads in the uh, high percentage of a duty cycle. If we set, so now I setting red equal to 10 percentage, and second LED equal to 50 percentage, and third LED blue is equal to 0 percentage. So now you can see the red is uh, glowness of a red is compared to green is low because it have a 10 percentage glow, and green is 20 I mean 50 percentage glow, and blue is completely off. So if I exit the second loop, again it will ask for within 2 seconds. So for this program I given two applications of automatic brightness adjustment and manual brightness adjustment. And our third question is to tell why. Let's see this video. You can see there is a light flickerance in the camera, and while capturing the indicator of a house line. So because this happen, as I say, the frequency of a camera is 60 per frequency 60 hertz. So the output of a indicator is less than 60 hertz. So that's why the difference in the frequencies matches, that leads to a flicker in the output. So this is the assessment of 2 and 3 combined in both video. So for another purpose, we can, since it's connected in pin number 12, 13 and 19, I have allocated the RGB LED same pins. So if we run a RGB LED program, it will automatically transist the colors between the three LEDs, because the RGB made of three LEDs, red, blue and green. So if we run a RGB file, so I am running RGB file. So this Python application to print 70 color smooth transition. You can see the color changes. The first red light is off, and green light is more brightness, and blue light is changing the brightness between the three colors. The combination of these three colors is RGB LED. So that will be inbuilt combination of these three colors. We can separate that, and we can observe that how the color changes from one color to another color. So this is the additional information of this video. So thank you. The code is, I will show the code for one by one. So after that, we want to stop the program and clean up the GPIO, which are the pins allocated in the mode. So thank you for this video. That's all in this video.